Okay, today's topic is called bisection method. This method is about finding roots of a polynomial. For example, you have a quadratic function ax squared plus bx plus c equal to 0. Okay, call this interval A. Okay, but anyway, this interval A and this A, they are not related, they're different, okay? They're different, they're not the same. Let's say you have the solution between interval A and B. Call this x1 and x2. You can solve this. You can solve this by factoring. Or if you cannot factor it, you use the quadratic solution formula. B squared minus 4ac. So there's a general solution exists. You can solve this easily. So we're going to show you how to use the bisection method to solve a problem like this. Let's say you have a xy axis, and then you have a polynomial or just a curve fx. So there's a root there at x2. It's an interval, say called the interval A, B. In this interval, within this interval, there's a root. So you're trying to find out the root. So let's say if you sample a point here, x1, just a sample point, sample x1, and then sample another point. One point x1 is before the root, and x2 is, x3 is after the root. So you can note here, if x2 is the root, then x2 is the root. If you plug in x2 into the formula, into the equation, you'll end up getting 0. So this means x2 is the root of fx. Okay? Do you guys agree?
Yes, yes, sir.
Okay, if x1, okay, if you plug in x1, and then if you get something like a value that's less than 0, that means it's going to be like a negative value, right? Right here. So negative value less than 0, that means x1 assuming x1 is in the interval, but on the left side of the root. It's within the interval. It's within the interval. X1 is within the interval. This is the bracket here, means interval, square bracket. It's within the interval, but it's on the left side of the root. This is the root, and it's sitting on the left side. Okay, if it's negative. Say fx3. If you end up getting greater than 0, then x2, let's say x2, assume that x2 is in the interval. Bisection method works only for functions with x-axis crossing. So if you have a function that's going like this, it's not crossing x-axis in this interval. Let's say an interval a, b. In this interval is not crossing x-axis. It's not in this class, right? Example. Okay, example or tutorial. The same thing, isn't it? I don't know. Given fx minus 3, let a minus b to be less than 0.01. Okay, minus 3. Okay, that's more correct. Okay, call this 1. And then 2. So it's crossing somewhere here. Trying to find this. Is it okay? Any questions?
No, sir.
No, sir.
Okay. Okay, let me just zoom this part. Let's say you have this curve like this. So this is your A is equals to 1, B equals to 2. One to 2. That's A and that's B. Okay, first step is step 1. Calculate Y values can now calculate the Y values corresponding to the interval A and B. A was like 1 and 2, right? Which means A and B. And this was 1 and this is 2. Okay, find out what is 1 and then find out what is 2. Plug into that equation. 1 squared, so is minus 2. 2 squared is 4. 4 minus 3 is 1. Okay. All right. Next, calculate midpoint. Calculate midpoint. What do I mean midpoint? Midpoints call this midpoint C. C, midpoint means I take the intervals, sum the intervals and divide by 2. The interval is left point is 1 plus 2, right point, divide by 2. That's going to give you 1.5. So what I'm trying to do, I'm just taking a point. I'm just taking a point in this interval. Okay, I found a point, maybe around 1.5. This point, the 1.5 can be here or can be here, we don't know. If it's on the left side, if this 1.5, if this 1.5 is on the left side, then you will get a negative number. Okay, if that is the case, then I have to let A to be 1.5. Then I should update my A. I should let my A to be 1.5. If C 1.5 gives me a negative number, then I should update my interval. So I can bring the interval closer to this point, closer to this point. Okay. Let's say we calculate your midpoint, and if a midpoint happens to be here, 1.5, and then let's say you end up with a positive number, that means you're on the right side of the root. Then you should upgrade your B with C, which is 1.5. Update. So that will bring this interval closer to the root. So the idea is you want to move the intervals as close as possible until B minus A becomes very, very small. You know, like in this case, we want 0.01. Is there any question? Okay, now let's try 1.5. Plug into that formula. We don't know where 1.5 is located. Okay, now we plug into the calculate y value. Which is going to be 1.5 squared minus 3, which is going to give you minus 0.5. Sorry, minus 0.75. So you want to know, you can go back, you're not sure where this point is. You can go back to the graph here. Okay, roughly say, okay, at minus 1.5, it is giving me a negative number, so that I must be below the x-axis. Let's say I'm somewhere around here. Let's say if I'm somewhere around here at 1.5, I got what? Minus 0.75. So now we can move the interval. Okay. In this case, I can let my A equal to C. Update. It's 1.5. So I'm on the left side. So I'm using. Therefore, you update. So from the graph, from the curve, I call this 0.1. I call this 0.1 just for your reference. From 0.1, from 1, it is understood that uh, 0.75 is below x-axis. Therefore, A is going to be C, and that's going to be 1.5. Updated. Updating A. So this is your new A. Now you calculate, next you calculate the interval. You just calculate B minus A, amplitude. B minus A now is B. What was B? B is still the same, 2. Your new A is 1.5. Is 0.5. call this now step 2. Just put step 2. Or just call this iteration 1. Call this iteration 2. Iteration 2. Iteration 2, repeat the previous step. Are you guys okay?
I'm good, sir.
Okay, repeat this previous step and calculate a new repeat the new step. Okay, now from just rewriting this. F2 is still the same. So we have a new set of coordinates here because we already updated our left interval to 1.5. The corresponding value is minus 0.5. On the right side is still the same. We haven't done anything yet. Now go ahead and calculate the midpoint. C is equals to 1.5. Like this is A and this is B. This is repeating the previous step. Divided by 2. Going to be 3.5 divided by 2. That's going to give you 1.75. After calculating this, we want to find out whether it's on the left or right hand side. To do that, we plug this into the original equation. It's 1.75 squared minus 3. Going to be giving you 0.0625. Go back, go to the curve, and you can plot this. For C value, you're getting a Y value of 0.0625. Assuming the Y value is 1.75 and you're right here. So yeah, these things are not to scale, okay? Maybe this curve is not very .75. 0.0, what did we calculate? 0.0625. Okay, now you are on the right hand side. So this is your root. Now you're on the right hand side of the root. If you're on the right hand side of the root, are you going to update A or B?
B, sir.
Ah, good. So if you update B, that means you're going to squeeze the the interval, squeeze the interval closer to the root. So everybody follow this? So do we know why we are updating B and not A? So call this point, I call this point Roman 1. Call this point Roman 2. Therefore, from 2 on the curve 1.75, for the coordinate 1.75, 0.0625 is above the x-axis. Therefore, is on the right side of the root. So therefore, we need to update the B. So our new B is going to be C, which is going to be 1.75. And the interval, the absolute value, we have to keep checking this. The absolute value of B minus A is 1.75 minus 1.5 is equals to 0.25. See the interval, the B minus where A value is becoming smaller and smaller. Okay, earlier, before it was 0.5. It was 0.5 here. Now it is decreasing. Now it's 0.25. Now let's do iteration number 3. This is iteration 1, iteration 2, now iteration 3.
Sir.
Yeah?
For the iteration 2, right? We finding is y bracket 1.75 equal to.
Why is it? Is it, you're asking why? Hello? Are you guys are still connected?
Yes, sir.
Yes, sir.
Yes, sir.
What was JJ's question? JJ? Why JJ is not connected?
Maybe the internet.
Internet or outer net?
Maybe internet is unstable, sir.
Why we are doing 1.75 is because based on our new, remember earlier on we came and calculate our new interval, uni interval. After calculating the new interval, after we calculating our new interval, now we getting a new interval. Okay, so that means if we calculate a new interval, then our C is going to change. For new interval, you calculate new interval 1.5 here, and then this is the same one. Then you're going to get a new C value. Once you calculate the C value, which is 1.75, so this C value is somewhere in between. This C value is somewhere in between here. So we need to plug this into the equation and find out what is the corresponding value. After finding the corresponding value, which is 0.0625, a positive value, so this will tell me whether the point is on the right or left hand side. That's why we need to plug 1.75 into the equation. That will allow us to determine whether the point is on the right or left side of the root. JJ, are you there?
Yeah, I connected, sir. Sorry, sir. My question is, we're supposed to written as y, am I right? Instead of writing as f.
F, yeah, y, fx. This is fx. This is fx.
But iteration.
And also same as y also.
Oh, okay, sir. Okay.
This is x-axis, y-axis. This is y. Also same as fx.
Okay, sir. Got it. Because in
This is
iteration one, we written as y only, sir.
fy, yeah.
Y, sir. In iteration one, we wrote as y. Yeah.
Supposed to be fx. Oh, that's a mistake. Where
okay,
is it?
Sir.
Where did I
Iteration
write? Huh?
one. Iteration one. Scroll down, sir. Scroll down in the example, iteration one.
Calculate y values. Also same as fx value. Same as fx.
Okay, sir.
Fx or y? Good question. If you are not sure, you should be asking. So this is a mistake here. Since I'm using f, so let me just use f. Also same as y, y is also function of x. So just for consistency, even if I put y 1.5, I'm not wrong, but just want to be consistent. So therefore I have to go ahead and write all these things as fx or y. This is x. Y also means y of x, same thing. So this is also same thing, f of x, or y of x, same thing.
Okay, sir.
Y of x, or is also y. 0.75, right? Just rewriting what we got so far. Calculate our new midpoint. A new midpoint. C is equals to, any question? So you take the endpoints or the interval points and divide by 2. Somebody is doing something with the mic on. Okay, so you calculate the new midpoint, then go ahead and calculate the corresponding fx value or y value. You know, same thing. 1.625 is equals to 1.625 So is this point below the x-axis or above the y-axis? The coordinate we have here is at 1.65, 625. The y value or fx value is minus 0.359. Are we below the x-axis or above the x-axis?
Below the x-axis.
Okay. Okay, good. If you guys, a lot of you don't know, if you're still not sure, this is the x-axis. So below the x-axis are negative values. Above the x-axis are positive values of y or fx. So we can go here, just for illustration purpose, we can come here. Okay, let's say I'm 1.625. Let's say I'm somewhere here. Minus 0.359. So now you can see it's below the x-axis. And what we have done, for each iteration, you're moving the interval, you're squeezing the interval to the root. So this is the Roman number 3. Sorry about the mess, but you know, So you can see for each iteration what we do in, we are closing in. But this is the root. Anybody, you know what's the root? The root is right on the x-axis. It's crossing, is the zero crossing of the curve. So it says below the x-axis, are we going to update the b value or a value?
A value, sir.
A value, sir.
Huh? A value, okay.
A value.
Since it is below the x-axis, we update the a value, right? Therefore, a becomes c, and c is what? 1.625. Okay, you should stop the short iteration once you reach 0.01. Right here? Somewhere around there. It doesn't have to be exactly 0.01. (1.75) minus 1.625. Okay, so now we haven't reached that value yet. We are looking at what? We want 0.01, somewhere around there. So that means you have to continue with this iteration. As you saw, or as you see, this is tedious stuff. So that's why people write programs. Some of the programs, you can write simple program, or you can write a more complex problem. So you just, the same program, all you have to do, you just have to change the subscript. Say for the iteration, then I have A4, right? A4, F04, all the calculation, equation is the same thing. Then next I come and I just redefine A5, you know, so it'll be much easier and less prone to mistake and less prone to heart attack. You can see like, yeah, after 7th iteration, then I got this. So this is the, after the 7th iteration, I get this. This is telling me B minus A is approximately, if I round up this, let me round this off. It is approximately 0.01. So we can stop here. Because I already reached the target. And this is where all these things are in tabulated form. Tabulated table format like this. So for assignment, what I would like you to do, just do what I have done. Okay, do this by hand again and do one more iteration. Not by hand. Just until 3, you do by hand. Then following, you do, just follow this. And then you do the 7th, we only have the 7th iteration, right? You do the 8th iteration assignment. and do until 8 iteration. Put your answer in a table. We'll continue tomorrow. Tomorrow about time?
8 o'clock, sir.
8 o'clock.
8 o'clock, Zay. Okay. See you all at 8 o'clock. I'm sure all of you know. Do you know, guys, know how to use MATLAB? Who don't know?